Hello everyone, I hope you are able to see the audio and the video clearly. Please let me know in the comment section on whatever platform you are watching. So currently we are live on YouTube and LinkedIn. Also we are streaming through vertical live streaming, which is the latest option available from the YouTube. So in the previous video of our AI live bootcamp, we have talked about like various stages of MDLC, that is model development life cycle. So we talked about how we plan it. Then we talked about data processing, development, and so in today's video, which is going to be the last video of our AI live bootcamp, we are going to evaluate and deploy our model. So like first we test our model and check, then finally deploy in the real world production world. Okay. So I hope the screen is visible in your screen. Please let me know if it is like you are watching the correct screen or how is it? Okay. Okay, so currently as you can see on my screen, like in the previous classes, we have done this model training. Like we have like started our training job and we have completed our model training. We also saw that our output of model is available in the S3 bucket, which we have provisioned for this, especially this boot camp. So like without any further delay, let's start today's demo of evaluating and a deployment of our AI model, which we have like trained already. Okay. So yes. So to deploy our model, first we need to like import CSV serializer class from the SageMaker ASD, which is going to help us to serialize input data into CSV format. Because like we want to deploy our model, which we have created, because we want to use it for the testing purpose first. Okay. So for that, you have to import this CSV serializer class from the SageMaker. Okay. So I will type from SageMaker serializers import, then press shift enter to execute it. So until you see a star here, that means it is still in the processing, it is still importing. And once you see a number here, so that means it has been like imported. It's just an info, it's not a like warning or error. So you can see this is an import that it is not applying like defaults. It's just not an error. Some people think it's an error because it seems like not applying SDK, but it's not. Okay. So we have imported our CSV serializer class from the SageMaker SDK. And basically the main use of this class is to serialize input data into CSV format. Okay. Now we are going to create an object which is going to help us in representing the model deployment endpoint. Okay, there should be an endpoint which we want to reach out in case we want to access our model, right? That's the basic use of deploying our model. Okay, so for that we have to create an object as SageMaker predictor. So our model is XGB, so I will name this as XGB predictor. And then like what is our model name? So if you go, you can see our model name is XGB underscore model. So we want to deploy this. So for that, XGB model dot deploy. And then inside it we are going to provide the details which is required for the deployment purpose of our model. So basically this is the method which we are utilizing to deploy our XGB model, which we have just trained as an endpoint on the as SageMaker, so we can make prediction out of it. like our customer is going to be churned or not. Like basically it is going to leave our organization or not. Basically that's what we basic purpose of model which we are to create this model. Okay. So for that, like let's start creating. So for that, like to deploy it, we should deploy it on a server or computer. Like our AI model should be on there for the processing. It should be on a computing system, right? So for that, we are going to like provide the details how many computers or how many EC2 instance inside it. We are going to provide the details which is required for the. So for that, we have to provide instance count here. So our model is very small compared to what real world production like model has been because it is for demo purpose. But the process will remain exactly same because like we are utilizing the data set of very small size, only 3000 records were there. But in real world, we have millions of record on which our model has been trained. So it requires like more CPU, more RAM to process and to work functionally. Okay. And also then second thing which we have to provide is instance type. So for that, you have to provide like which type of EC2 instance so it can like use it like how many CPU or RAM it is going to utilize. I have already told in the previous class like how you can check the instance type or you can directly go to this SageMaker pricing page. Okay, search for SageMaker pricing on your browser and go to this page and here you can just let it load. Okay, so like basically here you can load here you can see like what is the particular instance type you are looking for. It provides all the pages. So if you go to this notebook instances section and make sure so here you can see what is the instance size is available here, and you can see what is the like virtual CPU, how many CPU is there in this particular size, how many instance memory is there, how many GPUs are there. So accordingly, you can choose the instance size. We already discussed about this in detail in the previous videos. So I hope you are following that as well. Okay. So like put it like this and then we are going to use the serializer which we have just now imported. So it can be utilized to specify serializer. Here we are going to specify the serializer which is used to for the input data of various formats as like numpy array, list file or buffer or whatever you are utilizing. As our we are utilizing numpy array. So this like CSV serializer basically is chosen to indicate that input data should be formatted as CSV in the CSV format. Okay. So like we just imported it. So let's call it here. So like only these things are the like mandatory which you need to provide, like the format in which your data is going to come, like how many CPU or RAM you are going to require, you're going to tell using this instance type, and how many EC2 instance are actually going to require. That three details you are going to put it. Okay. So this deploy method creates a deployable model and configures the SageMaker hosting services endpoint and launch our model on an endpoint so it can host our model. Okay. So this is done. So let's XGB predictor. So let's run it by pressing Shift Enter. Okay, it is giving error. I guess because like we have taken it like we are doing this session after so long time. So maybe it's got removed from its memory. So I guess just we need to execute this like all these cells. So it will be really good for us. But for you, it will definitely going to work because I have taken so much time from the last previous session to this session, so it got removed from its memory. But no worries, it is not going to take much time. I just have to like deploy our model. So basically, we can start from yes here. So like, oh, this is a great way to revise as well. Okay, this is really fine for our last class that we are going to revise what we have done till now. So we have like first like deployed our mod like imported our Porto3 library, then connected with the S3, then we have downloaded file from actually we have already the output, so directly we can utilize the output. No need to like do it anyway. Generally, it remains in the memory. I don't know how it got removed, but anyway. So, like, let me just check we have test data or not. Okay, so for that, we need to again do it. Okay, then we have downloaded, like we have already put out the, okay, let's do the session, like revise. Like then we will download it from the S3 bucket. Then we imported the Panda library. Then we read this CSV file. Then we like run our like we see like what we have read it from it and we it in see in a data frame format as a Panda. These are the some commands which we have run. Then we have dropped our phone, which is unnecessary for it. Then we converted our area code into object type. Okay. Then here we have like utilize it for the making the observation. So we can select, okay, what is the like probability relation and like is data is biased or not to check or do the data analysis. We have run it like day charges, evening charges, night charges, international charges are basically same already connected inside the like day minutes, day calls. So like why repeat it? Because it will create a more bias towards these day and night charges if we provide the same data again and again, similar kind of format data. So this we have run it. Then we run the our churn like see how many rows and details like we remain before we get it into the model type. Then what we have done, we have like converted all these data because um, like model is cannot understand this yes no and all these like not numerical values. It can understand numerical values because it has to compare data on the base of like how is the is it like good, is it like it has to calculate based on the like we learn in the definition of machine learning, especially like it is going to predict the results based on the previous experience or the data it has got. Okay, so we are going to convert all these yes no into like 0 and 1 and different values. Okay, just like we he see here is the status case. So our model cannot detect like what is this case. So we have converted into 0 1 format. Okay, if state case is like if you look at it for the first data, state case is 1 and rest all values is 0. So this way it can detect, okay, this means this value particular case data I have to give you can utilize this from the pandas library get dummies and perform this action. So it will convert all these categorical variables into this numerical values. Okay. Then we run this model data. And then as per the requirement of our model, we are going to churn true at the very first place because it requires a label. Means what you are going to predict, it should be at the very first column. So we are going to predict if our customer is going to churn its services or not. Okay, means it is going to leave our mobile operating services or not. Okay. So for that, you whatever you want to predict your AI model means we want our AI model to predict if it is going to leave or not. So whatever you want as a result, you should put it as in first column and rest all the details which on the basis of what you want to predict, it should be at the later stages. Okay. So just enter it and now let's run model data. So So we can see we have got this result churn.true from the last of it has come in the very first place. We have utilized this uh, functionality. I already explained in the previous video. You can always check it out. Then we imported the NumPy library and then we splitted our data set. Okay. Then we have train data set, validation data, and the test data. Okay. Then we converted our both the data set into the CSV format and we imported the OS library. Then we defined a bucket variable. Then we uploaded this file there. Okay, this we already done, so I'm not going to do that. Then we imported our SageMaker library. Then we have defined the region. Then we defined the container as well. And then here by putting it into a different we have defined the training input and then here we are defining the test. So let's run it. This is only required inside the memory because okay, we have not defined the bucket for it. Let's do it. Execute it and now run it again. Okay, so this got executed. So now let's come to our main motto of our this class that we are going to deploy this. So now execute it. So it is getting self.ensure latest training job. Okay, looks like we have to train it again. Hmm. Okay, let's do it. I should check it before the class, but anyways, thanks guys for the cooperating. Let's run them again. So we have run the trace input. Now let's set the hyperparameter fitment. So this will start our training job. And you can see it has started the training job. We would be able to see it inside the SageMaker console as well. So if you go to the SageMaker, let's open it in a new tab. So also when it will be available, you can see a third folder in the like if you We will go to model output. So you will see a new folder here when our training has been done. This currently like it is downloading input data for our training, and in the training section you can see the training jobs. So in the console also you can see it is currently in the progress, and you can see the status here. It is now downloading the training image which we have provided here in the like image URI container, and you can see the container value which we have provided using this SageMaker image URI. We are fetching the XgBoost image from the Amazon ECR, which is available on the Amazon ECR, the latest Xboost image. Using the downloading progress, you can see all the matrices and the perform operations it's performing, the output configuration. It is will be available in the AI demo model output. So you will be able to see here. Okay, you can see a new folder has been created. So this is the latest folder which has been created. So currently profiler output has been created. Once like it is will successfully output. So you will see there is an output now. And this is our model into a tar.zz file, which is kind of a zip file where our actual model is residing. And you can see it is currently still in the uploading phase. So you can see it is utilizing which we have like provided to how maximum depth, and we have already discussed about these hyperparameters in the previous class, like how they perform and how deep your trees and how many nodes it can utilize. It you had provided here. So you can see its training job has been completed, and you are going to pay the bill only for what you have utilized. So now let's deploy this model. So let's execute this. So you can see it has created model with this name, created this endpoint configuration. It is still in the star. That means it is still performing its operation. But you can also see um, that here this training job has been completed for us. Now we have created the endpoint. So it should be available in the console as well. If you go to this processing job, and inside this inference, you can see this endpoints. So currently no endpoints is there. It is still in the process. As you can see, a star is still it is coming. Once it will be completed, then we can utilize our model. It will be provided endpoint through which it's like an URL for our website, basically. Just like I have in website kaustubsharma.com. So make sure you check that out. It has all the latest blog and included today's class blog as well. So it has all the latest details related to AI and ML. You can always check it out. It has multiple projects as well. You can always see all those code which I'm typing. If you want to like more in the reading format, then you can utilize it. But if you want to understand deeply, then make sure you subscribe our channel and watch all the videos related. It like very exciting content is going to come in the next few months. So make sure you subscribe our channel. So you can see it has like yeah, it's new only. Like we have created its endpoint configuration, and an endpoint also you can see there is an endpoint. It is currently in the creating stage. So once it will be done, we can access this endpoint to actually make prediction using our AI model. Okay. and see the actual fruits of what we have created. So you can see it is updating the endpoint. You can make changes to the endpoint again when it's in service. So currently it is in creating stage. Once it is in service stage, we are can utilize this. Okay. So once it will be done, we are going to perform like next steps, which is going to like see where what is the endpoint through which we can access it. Just like as I give an example, so there should be an like path or properly address, just like we have a URL address for like for our website or mail, which through which you can contact me through an email address, right? Similarly, to contact to a model, we require an endpoint, and so that you have to deploy it. So that we have already done, and once we receive this endpoint, we will like connect our model through that endpoint. Okay. So you can see this is generally in the format of like your algorithm basically, and then the year, then the month, then the date, and then your hours, minutes, second, and like millisecond. It goes to up to like in this format generally, which I see it is taking time. Okay, for here it is completed, and let me refresh it here as well. You can see, so the configuration, endpoint configuration has been completed. Let's see. Okay, we can see this our XgBoost endpoint has been in service now, and you can see an URL is here, and container logs. You can watch it here. CPU utilization, all this data will be available. So you can check this console page as well for like detailed description. But if you want to like just check what is the endpoint here through console, like if you in general, when you're working in a production environment, you don't get that much access to the console. Some of you might get, but not all the people, because there are different teams, and like we generally follow the principle of least permissions. So basically you can retrieve directly from here. Just type your predictor variable, that is XGB predictor dot then endpoint underscore name, then execute it. So you can see we can like we will get our model endpoint name. Okay. So this is like another way to get it. So we have successfully deploy our AI model. Now it's time to evaluate our AI model. Okay. So this is like the where we can see the fruits of what we have done now. So as like we have completed the like deployment part, let's start evaluating by creating a function named predict. So let's do it. So to create a function, we have to define it. Okay. And so what this predict function will do, it is we are going to utilize to make prediction using our XGB model, which we have just deployed on Amazon SageMaker. Because and we need to ensure that data is properly formatted, as we know like our test data, which we have splitted in our like previous sessions, and this also like we have split it here into three, our data set into three types: train data, validation data, and test data, three data sets. So we have already utilized this train data and the validation data in the process of training. Now it's time to utilize this state test data set. So we can evaluate model, okay, how much correct data it is giving, because it has all the details it is going to churn or not. So through this data set, we are going to test our model, okay, it is giving how the result, how it is performing, and how it is giving the result. Okay. So we need to make sure like this data should be in the properly formatted. As we can see, like our test data, it is currently into a NumPy format. Correct? It should be in the CSV format. Currently, it is in NumPy array. Okay. So, and it should be correctly sent to our deployed model endpoint. Okay. So for that, you need to first provide data to this predict function. So we provide two parameters to it: data, which representing the input data for which prediction are to be made, and it is as we are test data is in the NumPy format, so it should be in the format of NumPy array. Second, we can provide the number of rows that you want to process at a time. So it defaults to 500 rows generally, but it can be adjusted according to what your requirement is. Okay. So currently I'm going to put it as same as. Then I have to like basically uh, inside this function we have to define like what we actually want to do. Okay. So what we will do, we are going to first like split our input data, this data, input data, test data set basically into smaller arrays, with each array containing like a maximum of like rows which we have defined here. Okay. So for that, I'm going to put a new variable here and utilize the NumPy library to split it. Okay. Array split, then data, and then we are going to uh, like provide all the details like because we want to split it into the smaller arrays. Okay. And we have to like is- with each array we want to do it. So let's do it. And how many rows are there? Okay. So it contains a maximum of whatever the rows we have provided. Okay. Then let's create a new variable where we are going to store our like actual prediction made by our model, and results is, and then what we can we have to loop over each split. We whatever the split we have make of our test data set from that array to into this. So what we are going to do, we are going to loop it over each split array of data. So we can make prediction using our predictor, and these prediction are obtained as the byte stringer. So we are going to decode it and into UTF-8 from each string. Then we are going to concatenate into a single thing, and um, we are going to just it can be separated. So we are going to utilize a comma separator for that. Okay. So let's do it. So to of course loop it, we are going to utilize the for loop, and yes. So split array for every array, because we have splitted our test data into multiple things. So now for every array, we are going to loop it. And for our prediction, we want to store into such format. Like it should be separated by n comma, and it should be like we are going to utilize the join functionality here, and every predictions we can put here, and whatever the prediction made by our predictor, which we have already defined here at the endpoint XGB predictor, through which we are going to perform our basically utilize our endpoint. Okay, XGB predictor, then we are going to call this function, and then here we are going to pass this in. And as I said, the like result will come into like byte string, so we have to convert them into a string. So for that we are going to utilize this decode UTF-8. So it will be converted to strings. I hope this is clear to you guys. If you have any doubt, please let me know in the comment section. Okay. Then final, we are going to return the end results, and like basically converts all the whatever we have concatenated all these results here after we get it from like from the basically the result from our model. We are going to concatenate all them and separate it by n comma. Then what we are going to convert all these concatenated prediction string into a numpy array again using this np dot from string functionality, which is going to help us to convert it. And also we want to exclude the leading comma from the concatenated prediction. Okay, because they are going to separate it by comma, so we have to remove that here, because we want to get the result in like a numpy array, so we can see a proper formatted results here. So what we can do, we can like utilize prediction one, then it is done. So let's execute it. So it has been completed. Now it's time to call this predict function which we have defined here, so we can make the prediction on the test data. Okay, so this is where we are actually going to make predictions, and we are going to store it into this prediction variables. Okay, okay. Let's call our predict function, and let's provide the input as test data. And like we are going to test data is converted to, we have to convert into a numpy, so we are going to utilize 2 underscore numpy to convert into a numpy array from a panda data frame which we have. So this you can see here, this is provided because I know only like I have to pass only the features to the like our model. So if you see this test data, so first is a label which we want it to predict. I don't want to pass it to like a model. I want to only pass the input. Okay, you predict what is the it is going to predict. Okay, this is going to churn or not. Okay, and based on this data, it is going to churn or not. So this is like data set say it has already churned. So let's see if it is going to predict it or not, like this person is going to be churned out on. Okay, so for that I don't want to pass the label, so first column I have removed from here. Okay, I want to just pass the features only, not the labels. Okay, so it basically um, slices all the rows and the columns starting from the second column. Okay, and here in the prediction this will going to contain the prediction made by our model for the test data, and these prediction um, can be evaluated against the actual labels to like see how is our model performing, or basically to see the model performance. So let's do it. So it has been executed. Let's see the predictions. So you can see we have got the results. There are multiple results, but like yeah, this is not a like we are not able to get it. Okay, is it going to churn or not? But like this is in a array format. So like the best way to get it for a binary classification model is to generate a confusion matrix. So what is this confusion matrix? The best way is to see it in Excel. So let me just create a new Excel file for you guys. So I can explain this. What is this confusion matrix I'm talking about? So basically, this confusion matrix provides us a summary of all the model performance, and basically, just let me- why Excel it is not working. Okay. So yeah, confusion matrix just provide a summary of all model performance, and we are applying on the test data set. So it shows us how many numbers are there for the true positive, how many numbers are there for the true negatives, false positive, and false negative. So like if you don't know what is this true positive, true negative, false positive, and false negative, it will be better to understand it on Excel. So I'm just trying to open it. I don't know. Today's internet is taking too long to. I hope the stream is going fine and the audio and video quality to you is good, or how it is going to perform. Let's see. But confusion metric basically allow us to evaluate the model's ability correctly and classify instance into basically. Let me just open in simple notepad only. The best way to show you that only. Or I can show you here only. So basically, it is generally a table. Or why don't you I show you by actually executing? So it will be the best way. So if you guys can see it when I am actually doing. Okay. So for that, you have to utilize the Panda library to generate the confusion matrix, and you are going to utilize this cross tab. We have already utilized it previously also, so you should know about it. And here you have to provide the index, basically the actual labels or the index for it. Okay, where what you want to basically predict it. So in our case, we want to predict the like it is going to charge churn or not. So it is allocated at the very like at the very starting of it. Okay, so for that it will we have to provide that index. So for that you have to do test underscore data dot local location, then you have to provide this zero. Okay, so basically it specifies the actual labels from the test data, and it selects all the rows of the first column of the test data frame, and assuming that the first like column of data contains the actual labels, which is in our case it is containing the churn. So here we are just providing, okay, this is going to be our index. At the index we want of our confusion matrix, and then in the like column section, what we want. So in the like column of our confusion matrix, you have to provide the predicted labels, like what you want to actually predict from it. So we have provide the index what it is like what the so basically here it is it has already happened. It is the previous data. So that means this is like these are the actual they have been churned or not. But in the column section, we have to like pass the data which it has been predicted, like this data. Okay, it is currently in 1 0 format. So generally like the higher like from data representing it is going, there are chances to churn this customer, and like the lower it means it is going to not churn. Okay, so like here we have to pass like what is the predictions, like what our model has been predicted. Okay, this is going to churn on. Here we are passing the actual chance, and here we are passing the like what our model has been predicted. Okay, the like predicted labels for our confusion matrix. Okay, and so let's pass it. And also we want to, as you can see, we want to round them off. Okay, because we want to round them off to the nearest integer. And because these are the like basically into an decimal format, so we have to pass it. And also we will pass it to the nearest integer whatever they have. Okay, so let's do it. NP round, then we will pass the predictions here. Okay, and then in the rows name I can, so we have passed the row names as actual, so just provide the row name as actual. Pass the column name as well. So this we pass as prediction. So okay, so we have like whatever the label you want to give to into a table, so you can provide it, or you can use whatever you want for the index access and for the column access. Okay, so these four details you need to provide to generate an confusion matrix. Okay, so let's run it. So this is the table it is going to, it has been generated. So you can see like this is how it is basically. Screen is not visible to you guys. I hope screen is now visible to you. Yes. Okay, so you can see like here into our it shows this confusion matrix, which basically represents our like all the true positives, true negatives, false positive, false negative. So let's understand how to read this uh, confusion matrix, and what is this true positive and true negative. So you can see, as I already told, this index is representing, so this first thing here, it is representing true positive. So true positive means here it is representing this actual thing, and here this is representing the predictions, like how much prediction it is. So here it means like how many, like you want you think that your model is going to churn off here. And here it is representing how much it has actually predicted correct. So yeah, like there are like two, your data says it is going to, out of all the data which we have, like how many records we have, let's check it in our test data. So we can see there are 334 rows are there. Okay, so out of that 288 is it has predicted correctly that they are not going to churn it off, and our model also predicted it is not going to churn it off. Okay, then here it is uh, it is representing false positive. Okay, the above both things are positive representing positives, and below both these things are representing negatives. This means, what do I mean by false uh, positive? It means it says actual result says it is going to churn it is not going to churn off, but our model says no, it is going to be churned off. So these three details it has provided incorrect, and here it is representing false negative, which means it says our data is going to be churned off, but it okay, our label is churn equal to true, so it means it is not going to churn off here, but it says okay, no, it has our model predicted it wrongly, and it says otherwise. Okay, and here it is representing true negatives, so it means our model also says it is not going to churn off, uh, and actual data also says it is going to churn off. Okay, so these the more values you have in these two sides, it means your model is doing great. And if you have more values this side, that means your model is not doing great. The basic understanding is this. This represent true positive, this representing false positive, this representing false negative, and true negative. Okay. So in this true negative or false negative, so the true representing your model is doing correct. Okay, the higher the true values you have. So this is true positive and this is true negative. So your model is doing great job. It can predict the positive value as well, means true values as well correctly, and false values as well correctly. Similarly, here these are representing false negative. False means your model is not doing great, and in the case of positive side, it is only predicted 3 wrong results, and in case of negative, it has predicted 13 negative results. So this is a very fair share of our model really is doing great job. It is predicted really cool. So using this way, you can utilize this uh, basically utilizes this confusion matrix to evaluate our model performance. So, and you can just find out how many customers are going to churn actually or not. So congratulations, you have successfully completed this AI ML live bootcamp or AI ML project. Make sure you stay continuously learning and stay updated in AI ML. And make sure you subscribe to our channel. Follow me on LinkedIn as well. It's free for you, but it is going to help me a lot. So see you guys in the another video. We will keep coming up with the new content on AI ML, and I hope most chances are the next videos are going to come on the interview series or the certification series. So if you are preparing for any particular certification, please let me know. If you are looking for any particular certification, because I am also planning to do a certification. Mostly in AWS. So if you are planning so, then we can learn together, and I will share the details like how I am planning to prepare for that certification. So make sure you subscribe this channel and see you guys in the next video.